So today we are going to review the first concept that we've already covered in class using special triangles, and then we're going to move on to solving for a missing angle. So our first question here is to evaluate sine of 120 degrees. So the first thing we need to think about is whether 120 degrees has a related acute angle that's one of our special angles from our special triangles that I have drawn at the top of the page. So the first thing that we want to do is draw a terminal arm for our answer, and we have 120 degrees would be over in quadrant 2. And then our related acute angle would be 60 degrees because 120 degrees plus 60 degrees is 180 degrees. So that means that we want to use our special triangle with a related acute angle 60 degrees over here. Now, because the question originally used the sine ratio, we are going to use 60 degrees, and the sine is the ratio of the opposite side of the triangle over the hypotenuse of the triangle. So we know that this is going to be equal to root 3 over 2. But then our last step is to decide whether or not that's going to be a positive or a negative value. So one of the tricks we talked about was using the CAST rule. So we know that sine is positive in this quadrant. So we can record that it's positive root 3 over 2. So the other type of question that uses these two special triangles here is solving for the angle. So we're given the ratio, but we need to figure out what the original angle was. So the first thing you want to do is you want to take a look at this ratio and see if it is made up of values from our special triangles. So 1 over root 2 could definitely be from this triangle here because sine of 45 is 1 over root 2. So we would then know that we are looking at a related acute angle of 45 degrees, but it also has to be negative because we have a negative sign here. So we actually have two locations where sine is negative and we have a related acute angle of 45 degrees. And those would be the two locations there. So from the positive x-axis, to get to our first terminal arm over here, we are going to have to do 180 degrees plus 45 degrees gives us 225 degrees. So that's 180 degrees plus 45 degrees gives us 225 degrees. So we have our first answer is 180 degrees plus 45 degrees, which is 225 degrees. Our second answer starts at the positive x-axis and goes all the way around to this answer over here, which will give us 360 degrees minus 45 degrees, 315 degrees. So we actually have two answers. 315 degrees is an angle that will give us a ratio of negative 1 over root 2. 225 degrees is the other angle that will give us an answer of negative 1 over root 2. So to do another example like this, let's figure out what cos theta is when the ratio is root 3 over 2. So again, the very first step is you want to think, is root 3 over 2 values from one of our triangles? And we definitely have a root 3 over 2 here. And then we're going to look cosine. So cosine means that 30 degrees has to be the related acute angle because we would have adjacent over hypotenuse. So we know that 30 degrees is going to be our angle that we're going to use for this problem. Now cosine has two quadrants that are positive. So we have one angle here and one angle here. This is going to be 30 degrees, 30 degrees, because these are the two quadrants where cosine is positive. So that tells us right away that our first angle is 30 degrees because the related acute angle is the distance from the positive x-axis to that terminal arm. And our second answer is going to be 360 degrees minus 30 degrees, which is going to be 330 degrees. Are our two answers where the ratio is root 3 over 2. Now, our next example is looking at 4/3. Now, there's an important lesson in this example in that cosine, in terms of its graph, never goes above 1. Also remember that it is the ratio of the adjacent side of the triangle to the hypotenuse of a triangle, and it is a right angle acute triangle, so that tells us that 4 cannot be greater than 3, but in this case it is, so this is telling us that we somehow have a triangle where the adjacent is longer than the hypotenuse, which is not possible. As 4/3 is greater than 1. And we can never have a right angle triangle where the adjacent or the opposite side is longer than the hypotenuse. So that one does not have any solutions. And our last example for this quick video is where obviously 0.61 is not a number from our triangles, but 0.61 is less than 1. So that tells us that we can definitely use our calculator to find an answer. So we're going to do 0.61 and then take sine inverse of that, and we get approximately 38 degrees, and we'll round it to the nearest degree. Now we also know that there might be more than one answer. So if the first answer, this is positive, so that tells us that our first answer is 38 degrees, but there's another positive answer over here. So this will tell us that the related acute angle is going to be 38 degrees again. But we need to figure out from the positive x-axis over to the terminal arm. So our first answer is going to be 38 degrees. And our second answer, again, because 38 degrees is approximated, we're going to use our approximate symbol again, is going to be 180 degrees minus 38 degrees. So we have 180 degrees, subtract 38 degrees. Gives us 142 degrees. So we have two answers, 38 degrees and 142 degrees. Now I would just remind you that we can also think about this in terms of a sine graph, because we know that the sine graph is approximately like this. We know the maximum height is 1, so 0.61 would be about here. And so we have 2 times between 0 and 360, where this would be 0, over here is 360 because that's one period, and there are 2 times that the sine graph is approximately a height of 0.61. And this first one would be 38 degrees, and this second one would be 142 degrees.